So we're going to get some practice at reading line graphs. So the faster you go, the longer it's going to take you to stop. And that's what this graph represents. It represents the relationship between speed and stopping distance. So the police would use this, for example, to measure your skid marks, and that tells you how long it took you to stop. And that means using this graph, you could then predict how fast you were going. But let's get down to more specifics and look at the first question here. What is your braking distance if you travel 80 kilometers an hour? So 80 kilometers an hour is a speed. So I'm going to look up 80 kilometers an hour. I'm going to find out what point that represents, which is this one right there. And I'm going to read across. And that's just below 40 meters. So what is your brake distance if you travel 80 kilometers an hour? 39 not 39 kilometers, that's wrong, 39 meters. Why is it meters? Because of this unit here. What is your braking distance if you travel 110 kilometers an hour? So going 110, that's halfway between 100 and 120, so approximately here. I'm going to draw a line straight up and then straight across, and it looks like it's about 70 meters. How fast were you traveling if your skid marks were 40 meters? So this time you're told how long your braking distance or skid marks were. So 40, I'm going to follow this line out and down. So it's a little bit higher than 80 kilometers an hour. So let's say about 82 kilometers an hour. And yes, that's an estimate. And what if you were traveling 130 kilometers an hour? Well, notice the graph only goes to 120. So this is where we use our graph to predict what comes next. So if we imagine that this graph goes a little bit further, and notice these are in spaces of 20, so that means approximately here would be 140, and 130 would be in between there. I draw my line up, and there's no graph, but could I predict what's happening? I think it's going to keep going like this, and then I follow it across. And I say, that looks like it's about 2 spaces up past 80, so I would say 100 meters. Now, do you know this point for sure? No, you are making a prediction based on the graph. That's called extrapolation, because you're taking the graph and drawing out what happens beyond the graph. Extra points you're putting beyond the points, so extrapolation. And then let's take a look at this graph of temperature. It measures the temperature versus the month in a place called Beaver Lodge, Alberta. So what does the graph tell us? The graph tells us that the temperature starts at approximately -15 in January, and then it goes up to a maximum temperature in July, and then back down in December. And if you live anywhere in Canada, that's pretty typical for all temperature curves. So what does the graph tell us? It tells us the temperature rises to July and then falls again between July and December. What is the temperature in Beaver Lodge in August? So in August, I take my point and I follow it back to the y-axis, and it looks like it's approximately 15 degrees Celsius. Always include your units when you answer your question. How long will the temperature be above 10 degrees? So in order to answer that, I'm going to take my 10-degree mark, which is right here, and I'm going to draw a straight line straight across. And notice it intersects the graph in two spots, here and here. Now, when is the red line or the temperature go above that 10-degree mark? And it's in this section right here. So it is between the month of, between May and June and September. So that's 1, 2, 3.5 months. Approximately. Now, what assumptions are we making with this graph? Well, we are assuming that this is a typical year and that every year is the same. And that there are no big weather events that are happening during the year that we are asking about. So that's the big assumption. Okay, let's take a look at this very complicated looking graph, but don't get scared. It's not any more difficult to read off this graph than it is the last one. What you'll notice for starters is that there's 3 curves. We're talking about the temperature of Toronto, and the red curve indicates the maximum temperature that is reached in Toronto, because every year is different. So this includes what the maximum temperature could be. The average temperature in a typical year is in pink, and in blue we've got the minimum temperature, the lowest that the temperatures are in Toronto. On the left side we've got the temperature measured in degrees Celsius, which is most common in Canada, and for our United States people, they tend to measure the temperature in Fahrenheit, and that's what the right hand side is. So if I wanted to find out what is the average temperature in July, I go to July, I follow the line up until I hit the pink curve because I want the average temperature, and the average temperature is in pink, and then I follow it across and it looks like it's 20 degrees Celsius. So to flip that question around a little bit, when is the maximum temperature higher than 50 degrees Fahrenheit? So Fahrenheit means I need to look at the right scale. Here's 50 degrees Fahrenheit. Let me choose a different color. 50 degrees Fahrenheit. And I'm going to draw a line straight across. There's 50 degrees. Now where does that meet the maximum curve? So the maximum curve is in red, so it meets it right here and again right here. And the red curve is higher in between those 2 points, in between point 1 and point 2. So how many months, or when is it higher? It's higher between April and looks like November. So it is higher temperature than 50 degrees between April and November. Let's take another example of a graph where you see several curves, line graphs on one plot or one graph. This is a graph about the average weight for girls between birth and 5 years. Notice that the horizontal axis, or the independent variable, is age, and the dependent variable is weight. So the age controls the weight. We're going to I'm going to show you how this percentile business works by looking at a couple examples. So take a look at this point here. It's on the green curve. It represents a girl that is 1 year old and has a weight of 9 kilograms. Now, because it is on the green curve, it is on called the 50th percentile. Now, what that means is that 50% of 1 year old girls have a weight that is 9 kilograms or lower. So where do these numbers come from? 50% is because it's on the green curve. It's 1 year old because of that place where I've data point that I've picked, and the 9 kilograms comes from here. So that point tells us that 50% of 1 year old girls have a weight that is lower than 90 kilograms. Let's try that again. Let's take this one. So this represents a child that is 3 years old and a weight that is 18 kilograms. So, and it is on the 97th percentile. So 97% of girls that are 3 years old have a weight below 18 kilograms. So there's a lot of information that can be gained from this kind of chart. So let's do a few more examples. How much does a girl weigh if she is in the 50th percentile at 3 years? So 50th percentile means 50% of the girls are above the weight and 50% of the girls are below the weight. So at 3 years, I'm going to go up to the 50th percentile, which is the green curve, and then measure across, and that's 14 kilograms. Next question, how much does a girl weigh if she is in the 15th percentile? So 15th percentile means you're going to be following this orange curve here, and 5 years is at the end of the horizontal axis, so it's right here. And she's going to weigh, if I read across, approximately 15.5 kilograms. What if I have a child that weighs 10 kilograms at 2 years old? What can I read from the graph there? So let's see if I can find a 10 kilogram child at 2 years old. So at 2 years old and 10 kilograms, that's approximately, that's approximately right there. There's 10 kilograms in 2 years, right there. Well, that is on the orange curve, which is the 15th percentile. So what that tells me is that my child is fairly low. Only 15% of children are going to be below that weight, and 85% of the children are going to be above that weight.